Today we have an absolutely awesome question from an old IB paper 2 exam. We've got a function. F of x is equal to the ln of 4x all over x. Okay, and this function is only defined for x values between 0 and 5, inclusive of 5, exclusive of 0. Okay, notice the question is worth 7 marks. No part A, part B, just 7 marks, which means that we're going to have quite a lot of steps, probably somewhere in the range of 5 to 7 steps to actually figure this one out. The question is telling us that there is a point P that has the coordinates 0.250 and a point Q that are on this curve. Okay, the tangent to the curve of F at point P is perpendicular to the tangent at point Q. Really confusing. Okay, because we got two different kind of tangents going on, and it's telling us that we need to figure out what the coordinates of Q are. First thing we're going to do is we're going to graph this just so we have a visual representation of what we're dealing with. Okay, let's check it out. Here's what the graph of this function looks like. Ln of 4x over x. You see that it shoots up past the x-axis, specifically at that point where we're given 0.250. It finds some local maximum at around that point, then it plateaus off. If we just remember what we looked at, this equation, or this looks something like this, as we just saw. So you're not going to be expected to graph this by hand. Your calculator helps you all the way. This is telling us that at point P, right here, at the point 0.250, we can draw a line tangent to this curve. Okay. Then they're telling us that at point Q, probably somewhere over here, there is another tangential line. If I draw it something like this, never mind my non-straight lines, that intersects, in fact, let's do this in yellow, that intersects right there, that tangent line at P at a right angle. Now, based on only that information, can we figure out what the coordinates for that Q point are? Yes, we can. Let's first work with the fact that we know a lot of information about point P, and we know a lot of information about the tangent at point P. And even knowing from the fact that we know what this function is, so first thing we're going to do is take the derivative of it, because it's always going to tell us information about slopes, tangents, gradients, that sort of thing. So we're going to take the derivative of f of x, f prime of x, of ln of 4x over x. We immediately see this is going to be a quotient rule kind of problem because we've got x variable on the top and bottom of a fraction. Okay, to do that, I always like to do that in 2 steps. So first, I'm just going to take the derivative of ln of 4x. In fact, let's write that a little bit prettier. 4x over here. The ln of 4x is just going to be 1 over 4x times the derivative of 4x, which is 4, so it's just 1 over x. And the derivative of the bottom, x prime, is just 1. That makes our lives a lot easier. So if we use the quotient rule, we take the derivative of the top term, 1 over x, times the second term, x, I'll do the canceling out later, minus the derivative of the second term times the first term. So we have the ln of 4x times the derivative of x, which is just 1, all over the bottom term squared. Okay, well, x times 1 over x is just 1. So I'm left with 1 minus the ln of 4x over x squared is equal to my derivative of the function. Okay, now this is when stuff starts to get fun. We can figure out what the slope is of the line P, or the line that's tangential to P, by plugging in the value at which P occurs. So if we plug in the value of 1 over 4, or 0.25, I prefer working with fractions, but either way is fine. We can plug this in and figure out what the slope of that tangent line would be. 1 minus the ln of, I'm going to write everything out to start with, 4 divided by 4, over 1 over 4 squared. Okay, well, that leaves us with 1 minus the ln of 4 over 4 is the ln of 1. Ln of 1 is just 0. 1 minus 0 leaves me with a 1. And at the bottom, I'm left with 1 over 16. Anytime I have a fraction like this, where it's, or within the fraction, I've got a fraction, you can always rewrite this as just 16, which means that the slope m of line P is 16. That also means now that we can figure out the slope of line Q. Because we know that it's normal to the slope of, or to line P, we know that the slope of line Q has to be the inverse negative reciprocal. The negative reciprocal of 16, nice and simple, is just 1 over negative 16. So that's going to be the slope of the line Q. Okay, we're almost there. The last step of this is to go back here to our derivative, and if we rewrite the derivative, say, okay, well, we know that the derivative of this function, I'm going to rewrite it here, 1 minus the ln of 4x over x squared. At some point, that function has to be equal to negative 1 over 16. If we can figure out what x value that is, that's going to give us the x value that corresponds to point Q. Don't worry, you don't have to do this algebraically. It would be a nightmare to do this algebraically. So what we're going to do is we're going to go to the graph of this new derivative and to see at what value does that equal negative 1 over 16. Let's go to the graph. So we're back to our graphing calculator. I've plotted it, you'll see here, the graph of the original function we had, 1 minus ln of 4x over x squared, that's our derivative, minus 1 over 16. And now we're asking the question, at what point does this value equal, well, this should be actually, sorry, this should be plus, boom, plus 1 over 16. The question that we're asking ourselves now is, at what point does this equal to 0? Because when we figure out what this equal to 0, that's going to be the x value that corresponds to giving us the slope, negative 1 over 16, which is the slope of that equation line that's tangential to point Q. I know it's a lot of steps, but let's just bear with it and go step by step. We go here, we can just trace our graph and we see that this function has an x value of, or 0.701 is when it spits out the slope of, well, in this case, 0. All right, we're back. So what this means is that if I plug in a value of 0.701 into this derivative, 1 minus the ln of 4 times 0.701 divided by 0.701 squared, this would give me a slope of negative 1 over 16, which we knew that because that was the slope we were looking for this point, this line Q anyway. But importantly, what we figured out using our calculator is that this is the x value that corresponds to. So to finish this up, the last step, we need to figure out what y coordinate this is for the specific point. And this is just simple. This is pretty easy. We go back to our original equation, ln of 4x over x, and we plug in 0.701 into that equation, ln of 4x over x. So now rewriting it, ln of 0.701 over 0.701. Let's go to the calculator, plug this in really quick. All right, using our calculator, we can then just compute the ln of 4 times 0.701 divided by 0.701 is equal to, should give us a nice value, boom, 1.4708. Finally, our final answer is that the coordinates of point Q are therefore 0.701 and 1.47. After all of that in the bag. Done. If you like this video and you want more, subscribe, follow, like, comment, all that jazz. More content coming your way soon.